Today we're going to talk about transformations of graphs. You are going to learn some tips and tricks on how to graph a complicated looking function in an efficient way. But first, let's recognize some basic functions, or sometimes we call it the parent functions. The most basic function is a linear function. The graph of a linear function is a straight line. So a straight line could go like this, going up from left to right, if it has a slope that is positive. It could also go down from left to right if the slope is negative. But either way, it is always a straight line. Now, among linear functions, we also have constant function, which is a special scenario. A constant function always has the form f of x is equal to b or y is equal to b. What it means is y is always equal to a constant. In that case, you should expect to have a horizontal line as the graph. And then we also have another special scenario for a linear function, which is called the identity function, where y is equal to x. In this function, the x value is always the same as the y value. So if x is 1, y is also 1. X is 2, y is 2. And same with the negative numbers. So the straight line should go right through the origin. Next up, we have a quadratic function. So the graph of a quadratic function is a parabola. Now, when you graph the quadratic function, I want you to pay attention and try to memorize some critical points. So to come up with some points, we can make a table. One column for x and the other column for y. And then we're going to come up with some values for x. Let's say x is negative 2. If x is negative 2, then negative 2 squared will give you 4. So y is 4. If x is negative 1, negative 1 squared should give you 1. X is 0. 0 squared will be 0. X is 1. 1 squared is 1. And if x is 2, 2 squared is 4. So let's plot these points. We have negative 2, 4. That's this point. Negative 1, 1. 0, 0. 1, 1. And 2, 4. And connect to these dots. You should get a parabola, with the vertex being at the origin. Next up, we have a square root function. F of x is equal to square root of x. Some critical points for this function would be, let's say if x is 9, then square root of 9 is 3. If x is 4, square root of 4 is 2. X is 1, square root of 1 is 1. And of course the point 0, 0. So plot these points. Notice that I never pick a negative value for x because in a real number world, we can't take the square root of a negative number. So we have 0, 0, 1, 1, 4, 2, and we have 9, 3. So it's looking like this. And it goes on forever to the right. Next up, we have the cubic function. F of x is equal to x cubed. For this one, some critical points. Using the same technique, you come up with some x value and some y value. Some critical points for this one would be 0, 0, 1, 1, negative 1, negative 1, negative 2, negative 8, and 2, 8. So let's graph. 0, 0 is here, 1, 1, negative 1, negative 1. Notice that x can be negative here because when you substitute it in, negative 1 cubed should give you negative 1. And next we have 2, 8, and -2, -8. Connect these dots. We should have the graph of the cube function. Next, we have the cube root function. Now, for the square root function, we cannot have x be negative, but for a cube root function, it is okay for x to be negative because you can take the cube root of a negative number. Some important values that we can memorize. Say x is 0, then y is 0. X is 1, y is 1. X is -1. Cube root of -1 still give you -1. And then cube root of x is 8, so cube root of 8 is 2. It could also be -8. And cube root of -8 will give you -2. So our graph will look like this. Okay, and then we have this graph here. Now notice that the cube root function looks somewhat like the cube function, except that it is now turned sideways. Next up, we have the reciprocal function, or the function 1 over x. Some critical points are, so we'll start with 1. If x is 1, 1 over 1 is 1. X is 2, then 1 over 2, that's 1/2. Next, x can also be negative, so let's throw some negative numbers in there. Okay, let's plot them, or we'll add 2 more. So x is, let's say x is 1/2. 1 divided by 1/2 should give you 2. And if x is -1/2, 1 divided by -1/2 should give you -2. So we're going to plot these points. 2, that's 2, 1/2, and then we have 1/2, 2. It's about here. And we'll connect these dots. Now, keep in mind that as your curve go toward the x-axis or the y-axis, these arrows part will get closer to each axis, but it will never touch. So similarly, we will have a graph that looks like this on this side. So there is the graph of 1 over x. And finally, we have the absolute value function, where no matter what x is, positive or negative, y is always going to be 0 or more. So we have some critical points. So let's say x is 0, y is 0, x is 1, y is 1. X is -1. Absolute value of -1 is still 1. And then 2 and 2 and -2 and 2. That should be enough for us to graph here. So 0, 0, 1, 1, -1, 1, 2, 2, and -2, 2. So the graph of an absolute value function will be a V shape with the pointy part, the vertex, will be right at the origin. So those are some basic functions or parent functions to get us started.